Hey guys, so this is a video of just tricky examples of exponent rules. So I assume you already know the exponent rules. If you are not familiar with them, I highly recommend you watch my lesson video. So without further ado, I'm going to just show you the 6 examples I'm going to go through. So here are the first 3, and then here are the last 3. So they're kind of long. So I'll show you this one more time and you can pause if you want to. So if you want a copy of these just already written down, my guided notes at divideandconquermath.com already have all of these. You can always pause the video and try some of these and then wait to see the answers. That's a really great way to use this video. Okay, so I'm just gonna jump right into these now. So starting with this first one, so you do, when you're not sure what to do, think about the order of operations. So with the order of operations, we would have to think about the parentheses first, and then really this exponent out here. So that's actually where we've got to start with each of these. So I will start with this little cluster right here, where I have to really distribute this 2 to all parts of this. So remember, this would be 3 squared, and then I would multiply all of the exponents by 2. Now remember, 3 squared, it's not 3 times 2, it's 3 squared. It's a really common error to accidentally multiply this by 2. So just recognize if you are prone to that error. Everybody's prone to certain errors with exponents. And then here, so now I'm going to multiply these exponents by 3. So this will be x to the 4th times 3, and then y to the 5 times 3. So there's kind of what's going on in the background. So this first part now is going to be 9. So 3 squared is 9. It's 3 times 3. And then x to the 4th, y to the 6th. So there's the first part. And then the second part, this will be x to the 12th, y to the 15th. Okay, so now from here we're going to use the product rule. So we're just going to add up exponents. So for the x's, we're going to add the 4 and the 12. And then for the y's, we're going to add the 6 and the 15 as shown. So this will ultimately be x to the 16th, 9x to the 16th, y to the 21st. Okay, so moving on to B here. So once again, thinking about the order of operations, so we really have to deal with the parentheses and the exponents first. So that's all you can start with. So sometimes people start trying to cancel here, but that would violate the order of operations. There's nothing you can really do until you've evaluated each of one of these outside exponents. So starting with that, let's start with the top. So remember, this is going to be 2 cubed, and then we'll call this x to the 15th and y to the 6th. So I just multiplied those exponents out. And then in the bottom, so all of this is going to be over x to the 4th, y squared, and z to the 10th. Okay, so now from here, what we've got to do is we've just got to line up really where do we have the same base. So the x's I can reduce and the y's I can reduce. I don't have another z. Okay, so now this will be 2 to the 3rd. 2 times 2 times 2 is 8. And then I can take 15 minus 4, so trying to simplify the x exponents, and then simplifying the y exponents. So I'll take the 6 minus the 2. This z to the 10th stays in the bottom. So my final answer is 6x to the 11th, y to the 4th, all of this over z to the 10th. Okay, so moving on to C here. So once again, so we've got to start with the parentheses and the exponents. Now, I've talked about this in other videos. I would recommend just trying to break this fraction out separately and thinking through that detail. And then you'll have, so we're going to take the 5 times the 2, the 7 times the 2, and the 3 times the 2. And then this second part of the problem, this 9x cubed, y cubed, all of that's just going to hang out for a moment while we simplify this. So to evaluate this part here, we're just going to square the top and bottom. So 2 squared is 4, 3 squared is 9. So remember, it's 2 times 2 and 3 times 3. Okay, now the rest of this is going to be x to the 10th, y to the 14th, z to the 6th. And now what can I do? So from here, I'm going to add up the exponents. Now, one thing I want to point out here is that there's a 9 in the denominator, here, and a 9 in the numerator here. So if you remember, I've talked about this a lot, the commutative property. So these two 9s are actually going to cancel each other out like that. So we actually don't even have to worry about them. So I'm just left with 4 x to the 10 plus 3 and then I'm going to add the 14 and the 3, and then I've just got this z to the 6. So this is going to be 4x to the 13th, y to the 17th, z to the 6th. Okay, so for D here, so kind of the same idea. So we've got to start with the set of parentheses first. So once again, I will write this out. So 3 to the 5th squared, and then I've got to multiply the rest of these by 2. And I don't even worry about this other part for a moment, okay? So we're just going to let that hang out because we've got enough to deal with right over here. So once again, I just square everything. So 3 times 3 is 9, 5 times 5 is 25. And then this is x to the 4th, y to the 4th, and z to the 14th. Okay, now this is going to be a little bit different from the last problem in that now I have this other fraction of this xy cubed over z to the 5th. Now, I find that there comes a point with exponent problems where like the amount of detail gets a little overwhelming. And so if looking at all of this is just kind of making your head spin, I recommend writing out more detail. So what I mean is just looking at all of this, kind of what goes on the numerator, what goes on the denominator. So rewrite the problem where you just kind of have everything in its right spot. So for instance, like these 3 parts here, this x, y, and z, is this in the numerator or the denominator? This would all be in the numerator. So here's what's on top. We have 9, x to the 4th, y to the 4th, z to the 14th. And then we also have this other xy cubed. All of that's on top. And then in the bottom, we have 25z to the 5th. So I like doing this because this kind of helps me to organize what I need to do next. So now that all of this stuff is in the top, I can see that I can add the x's and the y's together. So let me do that. And I don't want to do too much too fast. So this is going to be 9x. So this 4 plus this 1 will be x to the 5th. And then this will be y to the 7th because I'm taking the 4 and the 3. And now I'm just left with this z to the 14th over 25 z to the 5th. So now I can see that I can actually take 14 minus 5. So I've got one more step to go here. So I've got 9x to the 5th, y to the 7th, z to the 9th, all of this over 25. And that's the final answer. Okay, so moving on to D. So for this one, I'm going to have to evaluate each set of parentheses separately. So starting with the top. So just a reminder, if this ever, like, if you forget to do this 3 to the 3rd, or if you're like adding them, I would recommend writing this out, like force yourself to write out this little detail, 3 to the 3rd. So this is 3 to the 3rd, x to the 15th, y to the 6th, z to the 12th. So I multiplied each one of the exponents by 3, and then I just wrote out 3 to the 3rd so I don't forget to evaluate that. So now let's set up the bottom. So this will be 6 squared. Now I multiply all of these by 2. So 2 times 2 is 4. This will be y squared, and then this will be z to the 6th. So now I can kind of see what I need to do next. So 3 times 3 times 3. I'm evaluating this right here. So it's very, very common that people will do either 3 times 3 when they look at this, or they will like add them, they'll kind of forget. So really remind yourself that this is an exponent. 3 times 3 times 3, that's 27. And then I've got x to the 15th, y to the 6th, z to the 12th. And then 6 squared, 6 times 6 is 36. Okay, so now what can we do next? So I like to really go one step at a time if you can't tell. So now I can see that I can use the quotient rule here with all of these. So the x's, I'm going to take 15 minus 4. With the y's, I'm going to take 6 minus 2. And with the z's, I'm going to take 12 minus 6. Okay, so let's continue this on over here. So I've got 27. So 15 minus 4 is 9. 6 minus 2 is 4. And 12 minus 6 is 6. Is there anything else I can do? Totally, I can still divide actually the top and bottom by 3, it looks like. So I'm going to divide this by 3 and this by 3. So I can simplify those coefficients, those numbers that are still in the problem. So this is 9, 9x to the 9th, y to the 4th, z to the 6th, over 12. Oh, wait, I can still go one step farther, can't I? I can divide that by 3 one more time. So see, sometimes it doesn't even pop out to me like what the best number to divide by is. It's like now it's like duh. But sometimes you just don't see it. So 3x to the 9th, y to the 4th, z to the 6th, all of that over 4. Okay. So just a few notes on this. So there's more than one way you could have gotten to this answer. And you didn't have to follow every single one of these steps, but you can't cross out the 3 and the 6 right here. Okay, you cannot violate the order of operations. You have to first evaluate the top and the bottom, and it's because you've got this set of parentheses with this exponent. The order of operations makes it very clear that that's what you have to do first. Now, you may have deviated a little bit from like the exact order of what I did, but this has to be your final answer. So if it's not, feel free to like leave a comment or email me or whatever, and we can kind of talk about it. A lot of times what I find though is if you aren't getting to this, it's usually because like you haven't written out enough steps. So everybody has kind of their like breaking point with exponents in that like there's only so much detail you can do at once. And so if you do too much detail in one step, you're likely to miss a step, if that makes sense. So last example here. So again, and maybe you want to pause the video just to try this out. So I'm going to start with the top. So I've got 4 squared and then x to the 6th, y to the 4th, and z to the 10th. And then in the bottom, this will be 2 to the 4th, x to the 4th, and z to the 8th. Okay, so now let's see. 4 squared is 16. And 2 to the 4th is also 16. So what does that mean? That means that the 16s will actually cancel out. So I can cancel those out entirely. So now I can really just use the quotient rule here with the x's and with the z's. So to finish this, I will take x to the 6 minus 4. I'm going to leave the y to the 4th alone. And then I've got z to the 10 minus 6. So what happens to the bottom since all of these things have gone away? Technically what happens in the bottom is there's like an invisible 1 in the bottom, but you can drop that. So you're just left with x squared, y to the 4th, z to the 4th, and that would be the final answer in this case. So those are definitely some trickier problems. So if you didn't get them the first time, or you can always go back and review them. Like sometimes just practice makes perfect, and again, a lot of times it really comes down to writing out a lot of detail and taking your time with it. But that'll wrap up this video, guys. Hopefully that was helpful. I'll see you guys next time.